the different types of lines we have with systems of equations. So when we're talking about we have three types of lines. So there's three types of lines. All right, the three different types of lines are, we can have intersecting, parallel, or we can have coinciding lines. So these are the three different types of lines that we can get with a system of equations. Now, intersecting lines, that's what we've dealt with so far. These are just lines that intersect, and intersects means that they cross at a specific point. Doesn't matter what that point is, they intersect, they cross each other. Now, we all know that parallel lines never intersect. So they never touch. So parallel lines, they run parallel to each other, they never intersect, they never touch, so there's no solution there. Now this last one, this coinciding lines, coinciding lines means it's just the same line. It means if I have this line, I drew this first line in blue. Now if I draw a second line, if you notice it overlaps this first line. So these are coinciding lines. They are the same line, they lie on top of each other. Now, we're going to talk about some different properties of intersecting lines. So a few things that we have to know about intersecting lines. Well, with intersecting lines, they have different slopes. Different slopes. Now, if you notice, if you look at these two lines, one of them has a positive slope, it's going up. The other one has a negative slope, it's going down, and they're going to intersect. Now, intersecting lines have one solution. That solution is where they intersect. So our solution is right here. This is our solution. So this is our solution. So they have one solution. Whereas when we look at parallel lines, well, parallel lines, they have the same slope. The same slope. So if this is going up to right 1, up to right 1, up to right 1, and it's going to keep doing that, well, the other graph also has to go up to right 1, up to right 1, up to right 1, so that they are going to stay the same distance away from each other. So they have the same slope. But what they have is they have different y-intercepts. So they have different y-intercepts. So if you notice, this y-intercept might be 0, and then we can say that this y-intercept is 4. So they have the same slope, but they have different y-intercepts. And now these lines, they have no solutions. Because they have no points in common. They never intersect, they never cross, so they have no solutions. And now with coinciding lines, it's the same line. So we know that this is the same line. So they actually have the same slope. And they also have the same y-intercept. Now the solutions for these lines is any point that we can think of, it's on both of these lines. So any point. So they have infinite solutions. So they have as many solutions as you can think about. For any point, the lines extend forever, so the lines continue to go. So any point on this line will be a solution. Now let's look at a couple examples. So if we have example 1, it says, are the following intersecting, parallel, or coinciding lines? Well, what we want to look for is this first thing. Well, we know, we look at these slopes. Well, we have a slope of 2, and we have a slope of 2. So the slopes, they have the same slope. So since they have the same slope, we look at the y-intercepts. So now we look at the y-intercepts. We have 5 and 8. Well, 5 and 8 aren't the same. So they have different y-intercepts, which means that these are parallel lines. So we know that these are parallel lines. They have the same slope, but they have different y-intercepts. Now if we look at question B, we have one that is in slope-intercept form, y equals negative 1/2 x plus 3, and the other one that is not in slope-intercept form. So what we want to do with this is we want to write the second equation in slope-intercept form. Well, by doing that, first step is we are going to subtract the 2x. So we have 4y equals negative 2x plus 6. Then we divide by 4. So y equals negative 1/2 x plus 1.5. Now we want to compare these two lines. So we want to compare these two lines. So I'm just going to write this underneath it. Now when we look at them, we first look at the slopes. Well, we notice that the slopes, once again, are the same. So they have the same slope, but the y-intercepts are different. So they have different y-intercepts. So that means these are parallel lines. So we have parallel lines again. And when we look at C, they're both in slope-intercept form. We have y equals 4x and y equals negative 4x. Well, if we just want to write plus 0 to show the y-intercept. Now, when we look at the slope here, well, we notice that the slope, well, we have 4, we have negative 4. Well, they're not the same. They look the same, but one is positive, one is negative. So they actually have different slopes. So these have different slopes, and we know that the ones that have different slopes, they are intersecting lines. So these are the intersecting lines, meaning these two lines are just going to intersect. And if we look at example 2, now it says how many solutions do the following of system equations have? So there's two ways we can do this. We can write them in slope-intercept form and then determine if they're parallel lines, coinciding lines, or intersecting lines. But there's an easier way to do this. Now, if we notice, these are lined up, they're written in standard form. So we have our x's are lined up, our y's are lined up, and then our numbers. So if we use our elimination method, what we want to do is we want to eliminate one of the x or the y. So now if I look at this first one and I multiply everything by negative 2, I'm going to box out my y's. So I want to make it both y's 2, one's positive, one's negative. So if I multiply by negative 2, I get negative 4x minus 2y equals negative 8. Now when we go to add these together, I'm boxing out my y's. So if I box out my y's, and 4 plus negative 4, that'll give me 0. 8 plus negative, that'll give me 0 also. So I get this equation that says 0 equals 0. Well, this is a true statement. So since we get 0 is equal to 0, it's a true statement. That means these are coinciding lines, which means they're really the same line. So if you go back and when we multiplied by everything, see how it's a 4x and a 4x, a 2y, an 8, and an 8? Well, they're the same line, so they're coinciding lines. And we know that coinciding lines have infinite solutions. So this first one has infinite solutions. Now when we look at the second example, we have 3x plus y equals 1, 3x minus 2y equals 4. So what we want to do in this one, we want to eliminate one of the variables here. Well, if we notice that we already have the x's, both of them are 3. So we can box out the x's. Well, one has to be positive, one has to be negative, so I'm actually just going to change all of the signs in here. So now, when we add these together, we're going to box out the 3x. And we have y plus 2y will give me 3y. 1 plus negative 4 will give me negative 3. We divide by 3, and we get y equals negative 1. So we know that y has a value. So what this tells us is that we're going to have a solution. So we can figure out the value of x by plugging y back in. So if we do 3x plus y equals 1, we plug in negative 1, 3x minus 1 equals 1, 3x equals 2, x equals 2/3. So we know that this has a solution of 2/3 negative 1. So that means if we have a solution, these are intersecting lines, and they will have one solution. And we actually know that the solution, it's 2/3 negative 1. And now when we look at f, well, when we look at f, we have, once again, the x's are lined up, the y's are lined up. So what we want to do is we want to box something out. Well, I'm going to box out my x's, so I'm going to multiply the entire thing by negative 4. So I will match up my x's, 4 and 4. So we distribute, we get negative 4x minus 12y equals negative 20. So now we can box out the x's, and we add these, cross them off. Well, 12y plus negative 12y is 0. 10 plus negative 20 is negative 10. Now this time we don't have any variables because they cancel each other out. We eliminated both of them. Well, just like the example letter D, we come up with 0, but this time it's 0 equals negative 10. This is a false statement. We know that 0 does not equal negative 10. So when it's a false statement, that means these are going to be parallel lines. And we know that parallel lines have no solutions. So these are the two ways that we can determine what types of lines we have. We can look at the slopes and the y-intercepts, or we can eliminate one, and if we come up with a true statement, such as 0 equals 0, we know that they are coinciding lines, and a false statement, 0 equals negative 10, we know that they are parallel lines. And if we can figure out the actual solution, they would be intersecting lines with one solution.